This is 3.8 day 2 homework. Okay, so 45 and 48 says to use a graphing utility to find your solution. So remember, you just type it in Desmos, you look for the x-intercept. The number 45 had an x-intercept of around 1.52, said round to the nearest hundredth. 48 had 4 of them, 0.92 and negative 0.92, 0.53 and negative 0.53. Okay, 51. We want to solve the nth root here, so we're going to use factoring here, so I'm going to add the 1 over. Notice it's a cubic pattern, so that's x times x times x and 1 times 1 times 1. Okay, so it'll be x plus 1 times x squared minus 1x plus 1 times 1 is 1. Okay, now to solve them, I know that x is equal to negative 1. This you're always going to have to use either the quadratic formula or completing the square. I'll just use quadratic formula. So it's negative b plus or minus the square root of b squared minus 4 times a times c over 2a. 1 squared is 1, minus 4, so it'll be 1 minus 4 would be negative 3. Sorry, the a is a 1 over 2. And the only thing we want to do there yet is take the I out. So 1 plus or minus I square root of 3 over 2. Okay, so we have 3 roots, 3 answers, so 1 and 2 and 3. Number 54 is x to the third is equal to 64. So once again, that's a cubic pattern here. So x to the third minus 64 is equal to 0. This is 4 times 4 times 4. So it'll be x minus 4. X squared, remember always opposite sign. 4x, and 4 times 4 is 16. Okay, so we know one solution, set this equal to 0, is x equals 4. For this one, I'm going to use completing the square because I used quadratic formula there. So you can use either though. Okay, if I subtract that over, I get this. Complete the square. Half of 4 is 2. 2 squared is 4. So this would be x plus 2 squared is equal to negative 12. Take the square root of both sides. Okay, and get x by itself, so it'll be negative 2 plus or minus. You want to simplify this. 12 is 4 times 3. Square root of 4 is 2. And it's negative, so it's I, 2i, square root of 3. Okay, so we got 1, 2, 3 answers for our x to the third. 57 is very similar. Okay, it's just equal to the negative instead of positive, but we're going to do it the same way. So you're going to add that over. Once again, it's a cubic pattern. So x plus 4 instead of x minus 4 up there. And then x squared minus 4x plus 16. Okay, so here I know that x is equal to negative 4. I'm going to use completing the square again. So it would be x squared minus 4x equals negative 16. Once again, half of this is negative 2. Negative 2 squared is 4. Okay, and take the square root of both sides and add the 2 and simplify this. Remember, that's the same as up there. 4 times square root of 4 is 2. Negative makes it I root of 3. Okay, number 60. We have x squared is equal to negative 52. So we have x squared is equal to, plus 52 is equal to 0. Okay, so you can't factor this. It's not a difference of squares or anything like that. So let's use a quadratic formula. Just to make sure you know this, it'd be like x squared plus 0x plus 52. If I use the quadratic formula, there's that term there. Actually, you know what? It'd be much easier. You could do that. You could use a quadratic formula. It'd be easier just to actually just solve this, wouldn't it? Okay, take the square root of both sides. plus or minus the square root of 52. Okay, the square root of 52 we can take out is 4 times 13. So we're simplifying it. So the square root of 4 is 2. Negative makes it I. And the square root of 13. So we have plus or minus 2I root 13 as your roots, your solutions.
Okay, so this is number 62. You can see I typed in the equation here. This is how you change the window. So if you go to the little toolbar there, we want our x's to be between 0 and 24. So we can put a 0 and 24 here. And the y-axis we want to be between 0 and 200. So we can type in 0 and 200 here. And this is what that graph looks like then. Okay. Part B asks us to find where the concentration is the greatest. Okay, so concentration is your y, so the y is the greatest at the vertex up here. And the vertex is 17.2, and when the concentration is 172.8. Okay, so that would be your maximum point. Part C, concentration greater than 100. Where is it going to be greater than 100? So if I put another equation in here, y equals 100. Okay, this is the line where it's 100. So from there to there, from time of 11.4 to 21 almost 2, it's always going to be greater than 100.
Number 62 we did with Desmos there, but there's the graph. And our vertex here, the max concentration is that at that time. And it's above 100 from that time to that time. 65. Okay, we got our cardboard box, cardboard sheet, that's 12 by 18. We're cutting out the corners here, and we're going to fold up the sides, so those make sides. There's no top to this box, but okay. So we have our bottom of our box is this, and these are the sides folding up. Okay. So restrictions on x. When I cut these out, I know that x can't be negative, right? So x has to be greater than 0. Also, for this to have a distance here, if I make it 6, if I cut out 6 here and I cut out 6 down here, right? If I cut out 6 here and 6 here, it would be leave no distance for the box. So you know it has to be less than 6 as well. Okay, for part B, the volume of the box. Okay, so I have to know the sides here. So this side would be 18 minus x, so minus 2 x's. And this side here, from here to here, would be, the whole thing is 12 minus x is 12 minus 2x. So those are the length and width. 18 minus 2x and 12 minus 2x. And then the height of the box is this x. You can think about that folding up. Okay, so we got to multiply these together. 12 times 18 is 216 minus 36x minus 24x plus 4x squared. Multiply that all by x yet. Okay, so our volume of our box is equal to, it's going to be 4x to the third. Okay, this would be negative 60. So negative 60x times another x would be negative 60x squared. And then I have that times x is plus 216x. Part C, where will it be maximum? Okay, so go to Desmos, look at this, and look for the vertex. Okay, and that vertex is going to be about at the point 2.35 and 228.16. Okay, which means if x equals 2.35, okay, so if I cut out corners, of that size, then the volume will be 228.16, which is the max volume that it will have. Okay, for what value would be greater than 80. Okay, so once again, you're kind of going to look at that graph. You're going to look at where it's 80 for both of these and between those two. So x has to be between 0.42 and about 5. Okay, so this would happen out here at 5. This would happen out here about 0.42. Okay, so you can go to Desmos and look for those values there. Number 66. Okay, we have a rectangular gutter. I'm not sure if you got all that up there, but there it is. Okay, 66, we have a gutter that looks like this. Rain falls in there and so forth. Okay, it's 20 inches. We have a piece of metal that's 20 inches wide, and we're going to bend it up. Okay, so when I bend up and make these x, this distance at the bottom would be the whole distance minus x, right? If we just take that and fold them up on either side. Okay, so x has to be greater than 0. And if I made these 10 each, if this would be 10, that would take up the whole 20, so it would be no distance for this. Okay, it would be more of a V shape if it was 10 and 10, right? V shape, we want to have some distance on the bottom, so you know it has to be less than 10. Okay, we want the area. Okay, so area and equal the length times width, which equals negative x squared if I put it in standard form, plus 20x when you distribute that through. Okay, part C, area be greater volume, so you want to find the vertex. So once again, you could use Desmos, you could use negative b over 2a, however you want to find the vertex, and that comes up to be the 0.5 and 50. So that means if x equals 5 inches, then we have a max area of 50 inches. Okay, and then part D, where will be less than 40. Okay, so if you're looking at this graph, it goes like this. Okay, so if you're looking at it on Desmos, and we want to know where is it below 40. So you got to find these 2 points here. Okay, so we're not going to go below 0, right? So x had to be less than 0, and we're not going to go below 10. Okay. So from 0 to this at 40 here, that's like 2.76. So from 0 to 2.76, that'll be below 40. And then also over here, okay, so this point right here was 7.24. And it goes, we had a restriction, it can't be greater than 10, so from there to there. Okay, so yeah, look at it on Desmos, it's a better graph than what I just drew. And the last problem was number 73. Okay, 73, we want to go to Desmos, and yeah, I'll go to Desmos and type this in Desmos for us.
So here is the number 73. Copper in high doses can be lethal to aquatic life. Number of the copper concentrations after 45 days at various distances down the field. Okay, so C is the concentration there, X is the kilometers down the field. Okay, so we want to make a scatter plot. So remember, to get a good scatter plot, you hit zoom fit here. So there's our scatter plot. Okay, so part B wants us to find the quadratic line for it. So we're going to use y1 tilde. Quadratic is ax1 squared plus bx1 plus c. So here's the equation for that. So y is equal to 0.003 x squared minus 4.933 x plus 22.2295. Okay, something like that. You can round it if you'd like. Okay, so that looks like a pretty good fit. Okay, then part C asks us to do the cubic one. So we're going to use y1 tilde a x1 raised to the third, so cubic, plus b x1 to the squared, plus c x1 to the first, plus d. Okay, so there we get the cubic model. Okay, so you can take this to how many decimal places you want, but there's your a, b, c, and d for your equation. And then part D asks us which one is a better fit. Okay, they're both pretty good fits. They both go through the lines pretty well. If we look at the R squared model though, okay, with the closer to 1 it is, the better. And that's a really good fit, but the cubic one is a little bit better. So the cubic model is better. Okay, part E, concentrations above 10 are lethal to muscles. Where is this the case? Okay, so I'm going to put in here y equals 10. Okay, so there's that y equals 10. So above 10 would happen right here. Okay, so basically from 0, because you can't go below 0. So from 0 to 31, almost 32, 31.98. Okay, and then the rest of the time it's below here. Okay, so just here's where the concentration was too high.